Yeah, comes on everyone. Let's start off. Hope everyone has gone through the notes. The last thing that we did was this one, the bus problem. Great. Okay, let's go ahead. Others do keep your cams on. Dave, Dhruv, Karthik. Let's go ahead with one more thing. This is another, category of problems which are again quite important. Let's say this is your top view. We have a cat here, which is going in a straight line with speed u. We got a dog here, which is going with speed v towards the cat. These are some standard models. Uh, you should know how to do these things. Matlab, you should kind of remember them. If they ask you, there's only one way to handle them. The distance between the cat and the dog initially was L. So the cat was at a distance of L, and this is like how it is the perpendicular. And what is this dog doing? The dog is always chasing the cat. Now, when you say chasing the cat, understand. You must have, did you ever ran behind a bus or something? Let's say you're standing here and the bus is going like this. When the bus is going forward, you don't go like this and then you don't go like this, right? You don't do that. You keep looking at the bus and you're running behind the bus. This is how you chase it. So something similar happens here. The moment the cat goes little forward, so let's say the cat has come here, the dog must have come somewhere here. So the dog is always looking at the cat. The cat doesn't care about the dog. It is just going in a straight line. And if you wait for some more time, the cat would come somewhere here, still going with you. Now maybe the dog is somewhere here. I'll just call it D. It's going towards this. And this is what is happening, right? As the cat is going away in a line, the dog is running behind this cat, and it is always looking at the cat with the speed V. The dog is always looking at the cat and running with a constant speed V. So cat ka dog ka direction is not fixed. It's always like, it is changing. It The head is turning continuously as the dog is moving, the head is also rotating. So the meaning of that is the velocity vector is always pointing towards the dog. Velocity vector of the dog is always pointing towards the cat. And what is a cat doing? Cat is simply going in a straight line. Cat doesn't care. Cat moves horizontally with speed u. And v ka value is greater than u. So the dog ka speed is greater than the cat. So dog will eventually catch the cat, right? So the first question. This is the standard question. Like this is from Mirror Dog. Find the time when the dog catches the cat. Suppose if v is equal to u, meaning cat ka speed and the dog ka speed is same. Now the dog can't catch the cat. Then what is the minimum distance between them? What is the closest you can get to the cat? Find the acceleration of the dog at t is equal to 0 initially. Find the initial acceleration of the dog. So these are some really good ones. These are a different variety there. If you have not seen them before, it's difficult to try them. But yeah, give it a try for a minute or two, and then I'll explain the whole stuff. Hope the story was clear. So we have a cat which is just running horizontally. There is a dog at a distance L initially, perpendicular to that the cat motion. It starts chasing the cat. So the cat goes forward, the dog also will rotate its head. So it is always running behind the cat. Initially, V is greater than you. So the dog will catch the dog, find the time. The second thing, if V is equal to U, the dog cannot catch the cat because both are going at the same speed, but you will get as close as possible. So what is the minimum distance? And what is the initial acceleration of the dog? For case one, so for V greater than U. The first one is a standard problem. The second and the third, made it up. So that's how what will happen. They won't ask you the same question. They will keep adding things and subtracting stuff. Manav, Dhruv, your cams are off. Do keep them on. Think. Take a minute. And this problem you should definitely do it after the class once or twice, maybe after a week. Frankly speaking, it is like kind of you should remember. You see this question and you should know what to do. In the exam, you try to think. So even in physics, there are certain models where you have to remember them. There is no way out. You see a question and you say, like, oh, this is how I should approach this problem. Listen to this. Let me help you with this thing. This is a little different. So let's understand the whole story first of all. Okay. So we have the cat, we have the dog. I'll just call them C and D. So as the cat is going in a straight line, this dog is chasing it. So this is the path of the dog. So the dog ka path won't be a straight line, it will be a curve like this. And eventually, right, it will somewhere here. So this is where the cat and the dog meet. So that is a point where they meet. So now if you take an intermediate position somewhere here, the dog was looking somewhat like this. So at this position, the cat was going straight. So this was the scenario. So this is some intermediate position. Now, if you look at the dog ka velocity, the speed was v. At this point, if you take this angle to be theta, the horizontal component will be v cos theta. The vertical component will be v sin theta. So this v cos theta is the horizontal component of the dog's velocity. Now here, see, the speed is constant, but theta is changing. So here, theta is variable. Every time the dog rotates its head, theta is changing. Great. Next thing, let the cat be caught at time t. No. So when the dog catches the cat, they must have traveled the same horizontal distance. Horizontal distance, not the same distance. So the horizontal distance traveled by the cat and the dog must be same. Because initially they're on this line, finally they're here. So horizontally, this distance which I'm marking in blue, this must be same. The x coordinate must be same. Cat is going with a constant speed, so this will be u into time. Dog ka speed is changing, so you can't say speed into time. So we have to integrate v cos theta into dt. That's your horizontal distance of the dog. So this is your first equation. Now cos theta, I don't know. Time, I don't know. But this is ut by v. So I know integral cos theta dt. Any doubts on this page? So the idea here is the horizontal distance traveled by the cat and the dog is the same. That's the whole theme of this pitch. And here the theta is variable, so you cannot remove it from the integral. You're stuck there. Now the second part. Now great, this is coming. Now the problem is I don't know what is it cos theta dt. Now let's look at the relative frame. If you look at the cat, now the same thing, if I draw this picture again, if you check out this in the cat ka frame, now look at this velocity. Let's see what cat will think about the dog. Now, if this angle is theta, this angle is also theta. So if you look at these velocities here, this component will be u cos theta. This component will be u sin theta. These are the components of the cat. Let's stop the cat. Meaning, if you're sitting on top of the cat and if you look at the dog, what do you think? What to do relative velocity? Take the cat ka velocity and subtract from everyone. Remember? So this is the cat ka velocity. What were your components? U cos theta, u sin theta. And what was dog ka velocity? Dog ka velocity was v coming towards you at that instant. Now, how do you stop the cat? Take the cat ka velocity and subtract it u sin theta and u cos theta. U cos theta, u sin theta. This is what we did last time. Whenever you want to stop something, take its velocity, reverse it, and give it to everyone. Now, what will happen? The cat will think, okay, I came to rest. I'm not moving anymore. But what is this dog doing? The cat will think the dog now has a velocity v and u cos theta, v minus u cos theta, and 1 u sin theta. So this is what the cat will think about the dog. This v minus cos theta, v minus u cos theta is bringing you close to the cat. This u sin theta is making you rotate. So if you look at the cat ka perspective, right, it will feel as if the dog is, taking a curve and coming towards you. It looks something like this. Because see, the thetas are not constant. So thetas are continuously changing. So this curve will bend. So this is the path of the dog as seen by the cat. Because see, end of the day, the dog will come and catch the cat. So they should meet. It doesn't go in a straight line because thetas are not constant. Now here, if you observe that the path is really not that important, but if you look at the two velocities, what is u sin theta doing? U sin theta is rotating you. What is v minus u cos theta doing? This is the velocity which is bringing you closer to the cat, isn't it? So the important thing is that who is responsible for the dog to come closer to the cat? The velocity along the line. So v minus u cos theta is responsible, right, for decreasing distance between cat and dog. This is at least what the cat will think. Cat will think, oh, dog is coming towards me with v minus u cos theta. And because of this only our distance is decreasing. right? And from there, just give me a minute. Have a look at this. Yes, some delivery guy. Great. So V minus U cos theta is bringing you closer. So then we can write the formula integral V relative dt, right, is equal to relative displacement. Relative velocity into time is relative displacement. So this velocity will be integral V minus U cos theta y minus sine, because it is coming towards it. Since it is coming towards, it is minus. If it is going away, it would be increasing. That would have been plus. So technically, I should have taken it as U cos theta minus V, right? Because normally when what we do, we always take the increasing things as plus and decreasing things as negative. ऐसा सोचो. For example, if this was the origin, and if something is going away from the origin, we'll say this is U plus I cap. If it is coming towards, you will say U minus I cap. So distance is increasing, it is plus. Distance is decreasing, it is minus. So I'll write that anyway, negative, since distance decreases. Generally in max, right, the convention is always the functions are increasing. We always assume the functions are increasing and then we solve from there. People, if you're going to keep your cams off, I'm just going to remove you from the classroom. So then, yeah, you guys can figure out then what to do. Because this is not your first class. You have problem with your cam, you can just tell me, like, yeah, you should tell me before the class at least. Now be careful. What is relative displacement? X final minus X initial. What is X final? The displacement when the cat and the dog catches, which is 0. What is the initial displacement? L. That was the initial distance between them, vertical. Signs are important. So this would be minus of U cos theta dt is equal to 0 minus L. You mess up one minus and whole thing goes for a toss. So you should be careful. Understand why, where is a minus n coming? Because displacement is final minus initial. Finally, the dog is at the cat. So initial position was 0. See, now when you say relative displacement, cat was the origin, isn't it? Cat thinks I am the origin. Everyone is, all distance are measured from the origin. Now, if you simplify this, that will be V minus U cos theta dt is equal to L. This was your equation 2. Please have a look at this. Once we got these two equations, the job's done. So whenever you get these kind of problems, this is the only way to approach, right? A second way, at least I couldn't figure it out. If you guys have a second way, great. What was the process? First thing, horizontal distance is equal. Second thing, stop the cat and take the relative velocity. Now here you might ask like this, sir, we can do like this also. Yeah, there is actually one more equation here. Integral V sine theta dt, that is the vertical velocity must be equal to L, isn't it? But you'll get integral sine theta. Yeah, this is right. Because this vertical component is doing what? It is closing this distance, isn't it? The vertical y coordinate. Isn't it? But that's not useful because I don't know how to solve integral sine theta dt. So this is right. Equation is right, but this is not useful. Because the horizontal will give you x coordinate, the vertical should give you y coordinate, which is L, isn't it? When the dog catches the cat, what is the vertical displacement L? And then, yeah, so once we just get the equations, what is equation 1? Integral cos theta dt. Integral cos theta dt is u t by v. What is the second one? Integral v minus u cos theta dt is equal to L. This was equation 2. So this can be written as integral v dt minus u integral cos theta dt there. I don't know cos theta, I don't know dt, but I know what is integral cos theta dt. Take this and substitute here. Integral vt will be vt. This will be minus u ut by v is equal to L. We'll get time is equal to v into L by v square minus u square. This is a standard result. Something like this comes, people do remember the result actually. But you should know the process. Because what will happen, right? You get a lot of variations. Look at the second problem. If v is equal to u, find minimum distance. So what people do, they remember the answer. This question is from actually Eredov, the first part. The remaining two are not there in Eredov. This is something we made it up. So if something changes, you should always come back to the process. So knowing the process is important. What if the cat and dog are accelerating? They'll say like this. The cat is accelerating with an acceleration A and the dog is accelerating with acceleration B. The speeds are always increasing. Then find the time to meet. Then you're gone. So getting it? So advanced में ऐसा होता है. It is not like, see, advanced में questions don't repeat, but patterns do come in one form or another form. All clear with the steps? Main thing is to get the equations. Once you get them, it is done. So this equation came from stopping the cat. This equation came from horizontal distance traveled. So we did one in the ground frame, we did one in the cat ka frame. Now using all this what I taught you, now you try, if suppose v is equal to u, if the cat ka speed and dog ka speed is equal, then what is the minimum distance between them? And the hint is simple. You still have to do the same thing. There's nothing new to do. You still have to do the horizontal, you still have to do the relative. So these pages will remain same, but what will change? Think, take 2 minutes. If you ask me, first of all, try to draw a picture. See, when I started the question, what did I do? I drew a picture, right? Oh, let the cat be here. Let the cat and dog meet here. Sometime in the middle, it looks like this. Draw a picture. Don't be lazy. When you don't draw a picture, means you didn't understand how to approach only. Drawing a picture is an important skill. So any confusion on this, ask me. It should definitely do this once or twice. And frankly speaking, ratta marna. You have to remember this model. Examine you see this question, people will get scared, but you are like, oh, I know what are the steps. Mechanically, you should do it and get it done. In physics, you will find there are like some, few models, like maybe some 7, 8 models which are there. You have to remember there's no way out. If you actually see, it looks more like math, right? At some point. And one more thing, if you notice, even though we use integral and all, we actually never integrated anything. We had integral, but we never integrated anything. We just eliminated that cos theta dt. Try. Today's class will be an important one. Okay, let me show you the picture, did you get the picture right? So how will the picture look like? So for the MP part, you might think like, oh, sir, how will we get ideas like this? Now, don't think like that. Think like this. Oh, this is how we do this thing. Now you learned how to get an idea for this, right? See, in life, when you're learning something new, sometimes you have to see something new, right? It can't happen like you're just sitting there and suddenly you'll get ideas. Unfortunately, that's what people think. See, tomorrow if you become an architect, you know what is the first thing you'll do? They'll give you 100 different buildings and they'll say study all of them. They'll indirectly say ratta maro. Because tomorrow when you're designing a building and when there is a problem, you should think like this. Oh, the 57th building had something similar issue. So let me take a solution from there and try to use it here. See whether it fits. Oh, this 92nd building also had something similar, but there was another problem with the material. So you need enough context to understand. So you can't think in vacuum. That's what I keep telling you. Have to remember anyone who says na physics mein ratta marne ka zarurat nahi hai, meaning you're lost. Trust me on this thing. I'm not saying remember everything. You should know your standard models. You should know your standard process. Then thinking comes. So if anyone of that opinion, ratta nahi marna hai, you will be very slow in the exam. You will not be able to handle them, and that's not the way to learn. Also, certain things you need to remember. So this is one of them. So what is the story now here? So the B part, they have same velocity. So this is my cat. This is the dog. So the cat is running happily. The dog is trying to chase, but now it cannot catch. So eventually the final picture will look like this. This is the dog. This is the cat. They have both come onto the same line. Now, because both are going with the same speed, do you think the distance between them will ever decrease? If you're running forward with you, if I'm running behind you with you, the distance between them is fixed, right? So this is the final distance x, right? So the minimum distance will occur when the cat and the dog come on the same line. That's the idea. You need to figure it out. So this dog has come chasing, and once it comes to the horizontal line, they start just running now. That's it. हो गया question. इसके बाद the dog cannot do anything about the cat. Great. Now going back to the equations. Now look at this. Who has gone more distance, cat or dog? Cat, right? Cat is ahead. So the horizontal distance by cat minus horizontal distance of dog must be equal to the x, which is the final distance between the cat and dog. Are you getting what I did there? I'm saying this distance, the cat ka distance, this distance is the dog ka distance. If I subtract them, that should be x, right? That statement is clear. What is the cat ka distance? U into t. What is the dog ka distance? Remember, that also became v, so which is u cos theta dt. And this thing is equal to x. Yeah, you can simplify this. Integral cos theta dt is equal to x. So this is your equation one. That same thing, ground trim, horizontal velocity, so you'll play one equation. Second thing, we will take that relative velocity stuff. I'll just copy the picture from here. You want to have a look at this page? Have a look at this once. We did the same thing. In the first part, what did we say? The distances are equal, isn't it? Horizontal distance by cat minus horizontal distance by dog is equal to 0. The difference is 0. Now it is not 0, it is x. I lost it. Same story again, the equation, right? We'll look again. This whole thing, the story is same. We just have to see what to change. That's what I keep telling. Once you know your process, right, just need to know where to adjust things. So same story. V relative is equal to this. So in place of V, you'll have U here. This also will be u, and yeah, this also will be u. This will be x final minus x initial. So this guy will be minus ut minus integral u cos theta dt. X final is x, x initial was L, isn't it? Now final is not 0, it is x. That's the distance between them. This was your equation 2. Meaning I can simplify this further. So this will be integral ut plus u integral cos theta dt. Send that minus that side. This will be L minus x. This is equation 2. Thus we got two equations. Ut minus integral cos theta dt is equal to x. Yeah, sorry, integral हो गया. This is u dt plus u integral cos theta dt is equal to L minus x. Add the equations 1 plus 2. If you add them, this guy and this guy will cancel. If you add 1, no, don't add them. Wait, I messed up something with a minus sign. This was plus, this was minus. And then you sent a minus sign that side. Yeah, L minus x. This was minus. Perfect. Okay. So take this and substitute there. So take this guy and substitute here. So this would be u into integral cos theta dt is ut minus x. So take this and substitute here. This will be ut minus ut. L minus x. Ut will cancel. We get x is equal to L minus x, and we get x is equal to L by 2. The second integral should be plus. Now it is fine, no, Yukti? Yeah, I did a mistake there. So this was the minimum distance. If the cat and the dog have same speed, the distance will be half of that initial distance. Again, just look at the equations. Solving part you can do. The main thing was how did you get the equations? Right. I used the same thing that I did in the before, right? Now tomorrow what they will say? They will say velocity of the dog is equal to 0.9 times velocity of cat. Okay, na question change. So you can't keep on remembering answers. Like if you remember the process, you can always do the adjustments. Tomorrow they will say the dog is accelerating. क्या change होगा? If they say the dog ka speed is increasing with a constant acceleration, that means constant acceleration means I can write v is equal to 80. So then the equations would change like this. So यहाँ पे you'll get an equation 80 cos theta dt, isn't it? Wherever there is u, you'll put 80. Wherever there is v, you'll put bt. And then you try to solve. Yeah, that's how you can keep playing around. All clear with this? Pictures are important. If you can't draw a picture, then you won't understand what is happening in the middle, how the end looks. There is still a third part, acceleration. So look at this. And if you see, right, they're only asking instant initially t0 only. Actually, in any other time, we can't find. So initially we can do. So initially, what was the logic? Initially, the cat was here. If you take a very small time dt, the cat must have traveled a small distance. The important thing is we take a very small time dt. Small time dt, the cat will travel a distance of u dt. Now this dog initially was looking at the cat at this position. Now suddenly it will move a little, but we can just adjust that. So velocity becomes towards this side. So the dog ka head turns a little in the dt time. Let the angle be d theta. So the dog ka head turns by a d theta angle. So speed of the dog remains same, but the direction changes. but vector rotates by d theta. Again, remember d theta is very, very small there. Ahana, which part? Which part you didn't understand? Which part? There are only two things I said. Cat in time dt, cat will travel u dt. In that small time dt, dog ka head also rotated by d theta. Right? Because if the cat goes little forward, dog भी उसको दिखेगा ना. So the vector is also rotating. Only at t0 initially, right? Small time, matlab just it started. Now, if you look at the triangle that we got, this is your d theta, right? This was your length L, and this is your u dt. So this can be written as tan theta, opposite side u d dt by L. For very small angles, you can write this thing as approximately d theta. So this is one of the approximations you should know. Maybe you guys don't know this. So if you're seeing this for the first time, remember this. For very small angles, when it's a small angles, theta less than 5 degrees, you can write sine theta is approximately equal to tan theta, approximately equal to theta. So for small angles, you can do that, right? So if I had to give you a little more on that, uh, I'll show it on the next page, but remember that. So we can do that approximation. Now, if you look at the velocity vectors here, what happened? Initially, it was v. So think of like this. This was v and this was v. This would be your change in velocity vector delta v. And this angle was d theta. It's like this. This is v initial and this is v final. And we know delta v is equal to v final minus v initial. So we can write like this. So v final is v initial plus delta v. Triangle of vectors. From if two vectors are joined head to tail, then the remaining vectors from remaining tail to remaining head. Now you can clearly see this is an isosceles triangle. From here, if you drop an angle, this will be d theta by 2, and this will be d theta by 2. Maybe I should magnify this a bit. This is v and this is v. So this part will be v sine d theta by 2. And this part also will be v sine d theta by 2. That means from here we get delta v is equal to 2v sine d theta by 2. And this actually we have done in vectors. Do you guys remember? If a velocity vector rotates by an angle theta, then the change in velocity is 2v sine theta by 2. Anyone remembers? We did this thing in, I told you it's a very important result. Remember this? I think we did it for position, I guess. Hmm. Remember this result? Delta V is 2u sine theta by 2. This was a question here, say. A particle is going in a circle with speed u. After time t, find the magnitude of delta V. Can you see the star here? So meaning if a vector, velocity vector rotates by an angle theta, then the change in velocity is given by 2u sine theta by 2. So this was done page 19 vectors. You can refer to that in case you didn't like this method. Page 109. Great. We got delta V. We got d theta. So d theta was u dt by L. Delta V or dV, you can say it's a small change in velocity is 2v sine theta by 2. Again, for small angles, we can write this thing as 2v theta by 2. The third part is a little difficult for you at this point because there are a lot of approximations. We get v d theta and take this d theta and substitute here. This would be dv v u dt by L. Send the dt that side. We get dv by dt is equal to u v by l. dv by dt is acceleration, and v is the velocity of the dog. So dv by dt will be acceleration of the dog, which is u v by l. Again, what it did, listen carefully. I said initially cat was there, it is going with speed u, so it will travel distance u into dt, small time. At the same time, the dog which is looking straight suddenly will turn its head by small angle theta because time is very small. This angle is d theta. This length was L. Then I said tan theta is equal to u dt by L. Because the time is very small, angles are also very small. When I say small angle, we are talking about 0.0001 degree, something that small. When the angles are so small, tan theta becomes almost theta. So basically, you can treat this like an arc, isn't it? So it's so small, you can treat it like an arc. So if you don't like this angle stuff, you can always say that L, and this is like your arc length L theta. So L theta is equal to u dt. So when you approximate this to d theta, see, you get the same thing. U dt is equal to L d theta. Isn't that the whole point of integration? You can treat an arc as a line or line as an arc because it is so small, everything works. So we got one relation from here. And then we said if a Doppler velocity is changing from v to v with an angle d theta, the change in velocity vector would be this. So this is your dv bar. This you should know 2v sine theta by 2. Again, same logic, since d theta is very, very small, sine theta becomes theta. 2 2 got cancelled. I took this d theta, substituted here. We got dv by dt is equal to uv by L. Okay with this. That's what the whole thing we did. Clear? That's it. Should definitely try this whole thing again, meaning literally this one problem took 45 minutes. Worthy problem, but this will give you a lot of ideas for other stuff. Like what you're seeing now will come again later on also. Great. A little about that sine theta stuff, right? Remember this approximation comes a lot. For small theta, sine theta can be equated to theta. Same thing. You can also say sine theta is almost equal to tan theta. Both work. So example, if I say sine 2 degrees, how much is this? When you say small theta, we generally say theta less than 5 degrees. Be careful, sine 2 degrees is not 2. You have to first convert it into radians. Sine 2 degrees is 2 into pi by 180 radians. This is a small number, sine pi by 90. So this is almost equal to pi by 90. Pi is 3.14 and by 90. That's a small number. Are you clear with that? Don't say sine 3 is 3. Sine ka value can't exceed 1. So when this is small angle, this is what you're talking about. You have to convert the degrees into radians and then you say that is equal to theta. That's one approximation. Very common approximation. If you're seeing for the first time, no problem, but remember this. You will see this thing at least another 15, 20 times in physics over the next 2 years. It's a very common thing. All clear with this problem? Cat and the dog. So this is called the famous cat dog problem. The first one is a standard model, pretty old question, cat catching the dog. But then over the time, we started creating more things. Like you can actually have more variations, but if you understood till here, you can handle most of it. Clear? Next one. Let's see. You can stay back after the class. This is another important model. So basically all these problems, right? These are called, chasing problems. Something is going and something is chasing it. All right. Cat and dog is one famous thing. And this is the second one. This is another famous problem. This also has a pretty good variations. We will see this again in circular motion. So we have three particles here, A, B, C. So there are three particles on the vertices of an equilateral triangle. They all are going with speed u. How are they going? They're going in such a way. This is an equilateral triangle of side A. A, B, C move with speed U such that A is chasing B, B is chasing C, and C is chasing A. Right? What do you mean by chasing? So if I have to show you a picture, it looks like this. Now, examine, they won't tell you all this. They'll simply say chasing. They'll expect you will figure it out. Now see what happens. A, which is here, the moment B goes little ahead, A will actually take a turn. Now because A took a turn, the C which is chasing A, C will take a turn. Because C took a turn, B which is chasing C will take a turn. So the three, right, they're actually chasing each other at some point of time. If you see, they're always moving towards each other. Next moment it will be here, this will be here, this will be here. So then this will be the triangle. So these particles are chasing. Let me show you the picture how it looks. Hmm. Can you see how the trajectory looks? That is how the path will look. So yeah, I here ABC velocities are in the reverse. So A is going this way, B is going this way, and C is going this way. So A is going this way, so B is chasing this. Because B is chasing this, C is chasing B, and because C is chasing and A is chasing C, you're getting? They're continuously rotating. This is how the paths will look like. I hope everyone understood what I mean by chasing. They're not actually going on a triangle. Understood now what happens? Initially, it was like this. Let's say this was A, this was B, and this was C. Let's say the moment B goes from here to here, the A who is looking here will suddenly turn the head this way. Na? Now, because A turned the head, C who's looking at A, C also will turn the head this way. Now, because C is looking this way, B who is looking at this, B also will turn the head this way. So they're chasing each other. Everyone is moving, they're turning their heads at the same time. You're actually spiraling out. This is how the path would look like. So the question, find the time when they meet and the distance traveled by A. This question we will again do in circular motion. That's a much better variation of this. This is still, here it is okay. Find the time when they meet. Now by symmetry, we know they'll all will meet. Find the time when they meet. Distance traveled by A. A, B, C all will travel same distance. So if we can find for one, we'll find the other ones. Yeah, let's get the question. Another standard model. Yeah, it looks a little weird and tough, but once you know it is easy. Like let's think about it. Take a minute or two. Again, when I say think, I'm not expecting you'll get an answer. Figure out, okay, in this it can happen. Okay, this can happen. Oh, this is what it is looking like. So figure out that insights. If there are 3 to 4 steps, figure out one or two. That's what I'm giving you time for. It's not to get an answer. If you got an answer, that is great. Okay, let's see. Yeah, Hannah, right. Right, Karthik. Now, listen to this thing. Don't look at the whole problem and get scared. Get the essence of it. Some observations. When you look at this, when you look at this thing, right, you will notice something. When these things are going, if you join them, the ABC, this becomes A, this becomes C, and this becomes C. You will notice something by symmetry, right? They'll always form an equilateral triangle. Can you notice that? If you join them at any point of time, you'll always get an equilateral triangle. Just because they are going with the same speed and they're initial on equilateral triangle. So that is the main thing you need to figure out. If you got that, I think that is like almost one third of the question. So by symmetry, we observe A, B, C always form an equilateral triangle. So at any time you stop them and you try to join them, you'll get an equilateral triangle. Always form an equilateral triangle, which is shrinking. The triangle is becoming smaller and smaller, and it is also rotating. There. That was the main observation when you see the picture. And eventually they will meet at the centroid because symmetry, right? Centroid is a symmetrical point. This much we can conclude. If you had figured this out till here, I think you did a good job. All got this? Now, coming back to the picture again. Now, since it always forms an equilateral triangle, A, B, and C, and I know they're going to meet at the centroid. If you look at the velocities here, look at this thing. So this angle is 30 degrees. This angle was 30 degrees. And this angle was 30 degrees. Now, if you resolve the velocities into components, so this is what you will see. So this was speed u. This was speed u. This was speed u. If you resolve this into components, the component will be u cos 30 towards the centroid. This will be u sin 30. B ka component will be u cos 30 towards the centroid, u sin 30. C ka velocity towards the centroid will be u cos 30. The perpendicular component is u sin 30. You said like, okay, after some time, let's say it rotates. Now remember, it still forms an equilateral triangle. After some time, the triangle must have become something like this. The centroid still remains the same. Oh, this was A now. Now, if you look at the velocity u, because it's an equilateral triangle, that angles will be always same. Now, exam, you won't do all this. This component will be u cos 30. This component will be u sin 30. So you'll notice something. No matter how much you rotate, the velocity towards the centroid, u cos 30 is always same, isn't it? No matter how much the triangle rotates, these particles are always going towards the centroid with u cos 30. So what are u sin 30s doing here then? The u sin 30s are rotating the triangle. Na? See, they're rotating the triangle. The u sin 30s are rotating the triangle and u cos 30s are shrinking the triangle. That u sin 30 part we will see in circular motion. So what we get from here is you will notice the u cos 30s are responsible for shrinking the triangle. Right? And ABC to meet at centroid. So this velocity is responsible for them to meet. U sine 30 is not important now, but U sine 30 is responsible for rotating the triangle. I hope everyone is clear what each velocity is doing. Once you figured this out, question is over. Now see, exam you will do this. You will say, okay, this is the equilateral triangle, this is the centroid. This guy is going with U, but technically you're going at the centroid. This was 30 degrees, this was point A. So your velocity towards the centroid was U cos 30. Then you will simply say the time taken to go to the centroid is simply the length AO by velocity along AO. If you want to go from A to O, then shouldn't you have velocity from A to O? Velocity along AO. And I hope everyone remembers centroid distances. The centroid will divide the distance in the ratio of 2 is to 1. So this distance will be 2/3 of height. This distance will be 1/3 of height. Where height of the triangle is √3 a by 2. This much I'm expecting, So this is a by √3. This is a by 2 √3. Substitute here. So the distance is a by √3. The velocity is u cos 30. Cos 30 is √3 by t, 2a by 3u. So exam में actually you will do this much. Is that making sense? So this is what you always do. Like you have to see where they're meeting and you see what is happening to the velocities and you finish it off. And what is the distance traveled? Now here, if you observe, the particles have constant speed. So distance is speed into time. Speed was u. Time was 2a by 3u. The distance is 2a by 3. So each particle travels a distance of 2a by 3. So that arc which you're seeing, this is how the path would look like. If you look at A, it is actually going like this. It will spiral like this. This is the path of A. Similarly, B also will look like this. C also will look like this. That is how they're spiraling. So length of that spiral path which you're seeing is 2a by 3. Is the concept clear? So what was the concept again? Because the particles are on a symmetrical shape and they have same speed, they will always maintain the same shape. Right? So they will always meet at the center. Second part, the velocity towards the center will always remain same. Third part, therefore time is nothing but distance towards the center by speed towards the center. And you're done. Is the logic clear? Now, can you do a few more cases? So based on this, I'll give you a few more. What if it's not 3 particles, but 4 particles on a square? A, B, C, D, side A. So A is chasing B, B is chasing C, C is chasing D, and D is chasing A. Same story. Find the time when they meet. I taught you for a triangle, but the story is same. Let's say there's a hexagon, 6 particles are there. But remember, the most important thing, the shape has to be symmetrical. You can't take any random shape and any random speed. Even if one of them is missing, the whole thing is gone. We can't solve this. So same story, A is chasing B, B is chasing C, C is chasing 6 particles chasing each other. I think by now you understood the theme. Let me take 10 particles, 10 sides, doesn't matter. For all of them, the idea is same. Let's see, get them. Now, once you got this logic, it'll barely take you 40, 45 seconds to solve the question. All that story that I'm telling you is like important. Exam, you won't do all that story. Okay, let's see. So this is a square. First thing, where will they meet? Center. Initially, A was the velocity. So you are going this way, U. So towards the center, what was the component? You can clearly see this angle is 45. So the speed towards the center is U cos 45. Therefore, time will be O to A by U cos 45. We know O to A is half of the diagonal A by root 2. Cos 45 is U by root 2. Answer is A by U. Same logic from here to here. What is this angle? 60 degrees and 60 degrees. So this component will be U cos 60. This is O and this is A. What is the time? O by U cos 60. What is AO? In a hexagon, all the centers, right? The distance is A. That is A. U cos 60 is U by 2. 2A by U. How long it took? Is that making sense? Don't look at all the story that I said, but once you understood how long it takes actually. So the whole theme is that who is making you go toward the center? The other guy is useless. That guy is making you rotate. But yeah. Any doubts on this? Clear? Now I can give you any number of sides. You can see the same question comes in the exam. You will be able to handle it. But a much better variation of this question will come in circular motion, where I'll ask you find the angle rotated by the triangle. After what time will the triangle become 180 degrees inverted and all? So that will be fun. But for that, you need to know this stuff. And just to show